Now let's talk about some basic properties of limits that are very useful. The first theorem says that some of the basic limits include the limit as x approaches c of b. Now in this case, this graph right here, b is a constant. As a matter of fact, in our example right here, this is the limit as x approaches, and we can pick any number. So let's pick, let's pick 1, because we're going to use 1 here in a minute, of b, and so b in this case is 4. Well, as I approach this from either side, I see that I'm always going to be approaching the value of 4. The second limit has to do with when we're dealing with the function that is equal to just x. The limit as x approaches any number, when f of x is equal to x, is simply that value. So, oh, I'm doing this in the wrong color. Let's switch this to green. Right here is my function, y equals x. Now let's pick 2. All right. So as I approach 2 from the left and from the right, I can see that the limit as x approaches 2 of x is simply 2. Quite literally what I've done is I've plugged 2 in to my limit. The third one has to do with powers. And we want n to be a positive integer, mostly because we don't want to be dealing with denominators at this point in time. And this is a graph of y equals x squared. So the limit as x approaches any number of x to the n is just that c to the n. So the limit as x approaches, let's pick a number. Let's pick, -1 of x to the n. In this case, it's squared. So this is -1 squared, or +1. And lo and behold, we see that is indeed the limit. Let's do a couple of examples, and I've put the basic limit properties up here to remind us. The limit as x approaches 2 of 3, well, we're using this rule right here, and so the answer is 3. The limit as x approaches -4 of x, using this rule right here, rule 2, this is -4. And the third one, the limit as x approaches c of x to the n, is what we're doing in part C. So the limit as x approaches 2 of x squared is 2 squared, or 4. And you do want to go and write out that 4. Now, some other properties of limits that I'm not going to prove to you are, again, more common sense. Suppose I have the limit as x approaches c of f of x, and that is L, while the limit as x approaches c of g is k. If b and c are real, they don't have to be positive, they just have to be real, and n is a positive integer, then if I multiply a limit by a constant, then that is simply the same thing as multiplying, I can kind of do this, multiplying the limit by that constant. So you literally can factor the constant out. If you're adding two functions, you can break them up. If you're subtracting them, you can subtract them. If you're multiplying two functions together, the limit as x approaches c of the product is the product of the limits. The quotient is the exact same. The limit as x approaches c of a quotient is the quotient of the limits, provided k isn't 0. Now, when k is 0, we're going to do some other things. And as we've seen for a power, we saw for x to the n, the limit as x approaches a constant of a function raised to the nth power is that limit raised to the nth power. So let's do a couple. The limit as x approaches 2 of 3x equals 6. Now, what steps did I use to get here? Well, what I said was this is equal to 3 times the limit as x approaches 2 of x, which is 3 times 2, or 6. I'm showing every painful step. You don't necessarily have to. What about the limit as x approaches 2 of 3x squared plus x squared? Well, the first thing we're going to do is break this up into the limit as x approaches 2 of 3x plus the limit as x approaches 2 of x squared. Now, this one right here, I'm going to write as a limit as x approaches 2 of 3x. All right. Now I'm going to come down here and plug this one in because I'm lazy. So the limit, 3 times the limit as x approaches 2 of x is 3 times 2 plus 4. So this is 6 plus 4, or 10. Now here's the product. I can multiply this out if I like. It's really not that hard. But let's see what happens if I use the product rule. This becomes the limit as x approaches 2 of 3x plus x squared times the limit as x approaches 2 of x. Now I already have this one from the previous problem. So this is 10 times the limit as x approaches 2 of x is just 2. So this is 20. The good news is you'll get to where you can do these very quickly. Let's look at the quotient rule. The limit as x approaches 2 of 3x squared, 3x plus x squared over x. How will I write this on a test or quiz? Well, this is the limit as x approaches 2 of 3x plus x squared divided by the limit as x approaches 2 of x. Now, I'm just going to go on, and when you get to the quotient and power rules, you can start skipping a couple of steps. So this is 6 plus 4 divided by 2. So this is 10 divided by 2, or 5. For the power, we can do a couple of things with this one. This is 3 squared times the limit as x approaches 2 of x squared. Now you see how I broke that up to start with? So this is the same thing as 3 squared. Oh, we've already done this one. So this is times 4. Oh, I did 2 squared in my head. Sorry about that. So this answer is 36.